Good morning everyone. I hope I am audible and my board is also visible to you. Today I am going to discuss some basic concept of the topic quadratic equation along with some very simple problems. Now quadratic equation, you have also learned this chapter in class 10 and you have learned or you know the form of quadratic equation. Just recall the form of quadratic equation. How it looks? It looks ax square plus bx plus c equals to 0. You all know that. Can I say this is a quadratic equation? No, it must have a restriction. And what is the restriction? A not equals to 0. In class 11, we mainly discuss the quadratic equation with real coefficient. Most of the problem you come across is the quadratic equation with real coefficient. That means A, B, C all are real. Now, if you want to recall or if you try to recall how to find the roots of the quadratic equation, there is a well-known formula called Quadratic method, and by using this formula, you can find the roots of the quadratic equation, or you can find the zeros as minus b plus minus under root b square minus 4ac by 2a. So a quadratic equation has two roots. One root is minus b plus root over of b square minus 4ac by 2a. Another one is minus b minus root over of b square minus 4ac by 2a. Now if I take this one as alpha and this one as beta, so alpha plus beta, that means sum of the roots, that means this one plus this one. You can see the denominator are same, so there will be common denominator and the numerator must be added, that means minus b plus root over of b square minus 4ac plus minus b minus root over of b square minus 4ac. Now this one get cancelled, so you get minus 2b by 2a, that means minus b by a. B is the coefficient of x, a is the coefficient of x square, so you will get alpha plus beta equals to minus b by a, where a is the coefficient of x square and b is the coefficient of x. Now product of the roots, that is this one and this one will get multiplied, minus b plus root over of b square minus 4ac by 2a into minus b minus root over of b square minus 4ac by 2a. Now denominator get multiplied with the denominator, so you get 4a square. Look at the numerator, a plus b, a minus b. I repeat, a plus b, a minus b. So what is the formula? A square minus b square. That means minus b whole square minus root over of b square minus 4ac whole square. So you get b square minus b square plus 4ac by 4a square, and 4 get cancelled, a get cancelled, you get c by a. That means coefficient of what? This is constant term, c is the constant term, and in denominator you can find coefficient of x square. So what is the product of the root? Constant term by coefficient of x square. Now very few basic things. One, a quadratic equation always have two roots. It comes from the formula, or you can say it comes from fundamental theorem of classical algebra. What it tells? Every algebraic equation having n degree, or every polynomial equation having n degree has n roots. So a quadratic equation has 2 degree, so it must have 2 roots. Exactly 2 roots. Now move to the next term, or this term. We call it as discriminant. Now, how you are able to find the nature of these roots? The key term is, or the discriminant is b square minus 4ac. We mark it as D. Condition 1. If D equals to 0. Now we can see the roots are minus b plus minus b square minus 4ac by 2a. Now if b square minus 4ac becomes 0, the root reduces to the form minus b by 2a. That means root are minus b by 2a comma minus b by 2a. So the roots are equal. That means when d equals to 0, the roots are equal. Condition 2, if d greater than 0. That means root over of positive number. That means again a positive quantity. That means it is a real quantity, and this are real. So you get the roots are real. So when d greater than 0, the roots are real and distinct. Condition 3. If d less than 0, that means root over of some negative quantity. When d less than 0, then you get a negative quantity under the root. A negative quantity under the root, that means it gives a complex number. That means if d less than 0, the roots are imaginary, or you can say the roots are complex. These are the working formula for this chapter. You have to memorize this.